The Formed Book Club. Catholic book lovers unpacking good books, chapter by chapter.
Welcome to the Formed Book Club. We continue to discuss Father Robert Spitzer's book, Science at the Doorstep to God. It has science in it, it's got philosophy in it, it's also got some sociology and psychology in it too. So it's an important book. It's difficult, worth discussing. But one thing I will say is that many things which he says in there, most anybody simply has to take his word for it. If he says this scientist says this scientist says that, here's your theory, we don't know all those theories. But so for that kind of a judgment of the book, we would need a peer to make that decision, right? But I think we can assume that he is reporting other scientists' findings as they are. And if there's any mistakes he's made there, there'll be criticisms of it. We'll find out what they are. But certainly, I think we can rely on him to give us a general overall view of what different scientific theories are speculating, about the origin of the universe and so on. So
two things I'd say to that, Father. First of all, he does give footnotes. So when he quotes, you can, if you're so minded, you can check on what he's doing. So I think he's been shown due diligence in terms of scholarship. And the other thing is that I'm a completely non-scientific person. I'm not in as regards physics, etc. And I'm actually learning a lot. I think you can grasp the general parameters of what's being argued, even if you don't know the mathematics behind it,
Exactly, that's right. So we had begun chapter 2, thus fine-tuning for life point to transcendent intelligence. The first chapter was about whether science, its findings point to a beginning of the universe. And he concluded from the various, scientific theories out there that yes, it does make it very, very likely that there was a beginning to the universe. Also, one of his methods, which I like, is that he'll take a position and he'll say, here's three theories on this, Now let's analyze all three. And here's the argument these people give, and then he'll go through and say, well, we can accept that one, we can't accept that one. So he's very, very thorough about presenting the theories and the critics of the theories and letting us draw the conclusion, or at least, vetting his conclusion. So we started chapter 2. We got as far as page 59, I believe. And so at the bottom of that page is section 2 of this chapter, 5 examples of fine-tuning for life and universe. Now, what does he mean by fine-tuning? He explained that in the first part here, that there are certain physical constants that we know are such. Well, pi is not a physical, it's a mathematical constant, but basically we know what the forces are between the protons in a nucleus. We know what the electromagnetic electricity is of a particular electron, all these things. And the idea of fine-tuning is that none of these things have to be the way they are. They could have been differently. But in this wide range of what they could have been, they happen to be in a very, very, very narrow range. And if they'd been anywhere else, we wouldn't have had stars, or wouldn't have had helium, or wouldn't have had iron, or whatever. So only if this constant was in a very small, infinite, almost infinitesimal sliver of the possible range would we have life at all, Well, that's fine-tuning. Of course, if you use the word fine-tuning, there must be a fine-tuner, right? It's not, the objection is, well, that's just the way it is. It's random chance. Well, when you get 1 out of a billion here, and then in addition to that, 1 out of a billion there, and 1 out of a billion there, it becomes so astronomically improbable that you have to say, wait a minute, what am I trying to do here? Explain by chance what clearly is more easily explained by a transcendent being, namely God. So he outlines the three areas he's going to look at for fine tuning. One, this is the bottom of page 59. The initial conditions of our universe effective at the moment of the Big Bang. Two, so what were the conditions there? Two, the constants of our four universal forces, gravitation, strong nuclear, weak nuclear, electromagnetic. And three, the masses of fundamental particles, quarks, protons, electrons, neutrons, etc. So there's one remark I want to make about this. Point number one, the initial conditions of our universe effective at the moment of the Big Bang. Well, how do they know they weren't there? You know, how do they know? Especially they're telling you 1 nanosecond after this happened, the density was so many billion kilograms per square, whatever, cubic. Well, how do they know that? They didn't observe that.
Are they working backwards?
They're working backwards. That's if they determine the universe is expanding, then they use the laws of physics that we know to say, well, it's expanding. You go backwards, smaller and smaller. As it gets smaller, it's more dense. As things start to bump against each other, there's friction. So we can calculate what we believe the conditions must have been at the beginning in order for it to be what it is now. So you're exactly right. But it does amuse me about how certain science can be about nanoseconds, fraction of a nanosecond at the beginning of the Big Bang.
Which was only 13.8 billion years ago.
Right.
I mean, that's a heck of a long time. So, yes, it does seem a bit, I don't know, presumptuous to be so certain about something that happened 13 billion years ago. But I guess if it all mathematically makes sense, then they can be fairly certain, right?
Yes. I mean, as long as they assume that nature is uniform and the laws of physics apply.
Well, if we can't assume that, then we're in trouble.
No science at all.
We can't even fly a plane.
But as regards scientific variables, so to speak, I like the quote on the next page by George Smoot, who the 2006 Nobel laureate in physics, because he gives the date of the Big Bang as 15 billion years, not 13.8. So what's a billion years between friends? But could I read his quote there?
Sure.
So this is George Smoot, the Nobel laureate in physics. In order to make a universe as big and wonderful as it is, lasting as long as it is, we're talking 15 billion years, and we're talking huge distances here. In order for it to be that big, you have to make it very perfectly. Otherwise, imperfections would mount up and the universe would either collapse on itself or fly apart. And so it's actually quite a precise job. And first of all, this is what I was saying, even if you're not a physicist, another mathematician, using these sort of, this isn't so much metaphorical, but these sort of prosaic explanations can actually penetrate even, the ignorant, such as me. So the whole idea that, if it wasn't perfect, it would just have expanded forever, making life impossible, or it would have collapsed in itself, which making life impossible. So, and the fact that you have to use language such as, well, perfection, imperfection, a precise job. I mean, it's a job and it's precise. It's precision. It all implies will, right, as opposed to accident.
And I'm sure in your literary mode, you also appreciated his image of the fingerprints of the maker. In the next paragraph, he used that expression, the fingerprints of the maker, about this discovery of ripples in the space-time continuum, whatever that is.
Whatever they are,
Yeah. But I thought ripples, when we see ripples on the water, we know that the wind, is or something. We know that something, right, has caused it. Yeah.
I mean, I'll be making some minor criticisms as we go through here, but I don't want that to make it seem I'm criticizing of the overall, principles or theses of this book. But I want to kind of do my own fine tuning in a certain sense. So at the top page 61, he says, perhaps the most striking example of fine tuning for life is the remarkably low entropy of our universe at the Big Bang. Well, okay. The idea is entropy is disorganization, it's corruption, it's dissolution. And we know that all activity tends to greater entropy, tends to more disorganization, tends to decomposition, and so on. So that's what entropy is. So to me, the fact that low entropy is very improbable and high entropy is more normal because it gets higher and higher as time goes on. The fact that we have low entropy at the beginning is not surprising to me. That's what the beginning means. Mm-hmm. It means that it hasn't started to degrade yet. So I don't see this as an example of fine-tuning because it's improbable to have low entropy. I'm just saying that's how the Big Bang had to occur if we realize, working backwards, as you said, Vivian, that at one point that was all in one place and therefore had low entropy. So anyway, I just thought that was a little tautology there.
Well, what is this point that he's making about without this low entropy, there would not be enough capacity for change, activity? He's linking this low entropy and high entropy with the capacity for any change at all.
That's right.
So could you explain that? What is that?
Let's say you have a spring sitting on the table with an object on it, and if you compress that spring, you're getting lower and lower entropy. And if you didn't have that spring compressed, it couldn't
expand.
It couldn't expand. So yes, without low entropy, you couldn't have any activity. Because we have high entropy, it means there's no more activity that can take place.
Okay, got it.
But again, to me, it's kind of tautology. That's what it means to start at a beginning like that.
Yeah. You gonna write Father Spitzer about that?
No.
I do like this one, just at the bottom there, because I like these metaphorical analogies. See, I was always told that that the probability of life or what have you was like a chimpanzee typing the whole of Hamlet. But what the metaphor was, but the chimpanzee has an infinite amount of time to type Hamlet, and therefore, eventually he would type Hamlet. But in actual fact, you look at this probability here, and I can't even not even how to say that the mathematical number there. It's this number, which is 10, and then that superscript 10, and then a superscript 1, 2, 3, 123 presumably, to the 10, which is 3 to the 10. So, but what he says here, and this is Roger Penrose, a physicist. This is Father Spitzer explaining what that figure, which was given by Roger Penrose. This number is so large that if it were written out with every zero being 10-point type, so normal typeface size, our solar system could not contain it. So that's just the number of zeros, number of noughts. It is the same odds as a monkey perfectly typing the manuscript of Shakespeare's Macbeth with random typing of the keys in a single try. And that's a huge difference, right? What are the chances of the monkey or the chimpanzee typing out the whole of Macbeth in one go, right, by pure chance? I mean, forget it. But they used to, my understanding was, but it's infinity. He just covers on type. Sooner or later, he'll get there. But what he's saying there is, no, this is so stupendously unlikely. The chimpanzee would have to type it perfectly the first time.
Well, since we're on this particular topic of probabilities, I want to jump forward to maybe a future chapter or something about the Bozeman brain.
Oh yeah.
Or the Boltzmann brain and the brief brain. And here's again, and I'll point to the text as we get along. It's minor criticism, although I think it has a major principle behind it. Namely, that the idea of this is that if there were an infinite number of opportunities for the universe to develop, then every possible combination would have been found, right? And therefore, there would have been a brain with memories of the past that we have, just like our brain is right now, and therefore, we don't. It's more likely that we can't distinguish between whether or not this is just all a question of chance. We happen to live in the universe where it all came together, and the atoms and molecules got into a formation that was a human brain with memories. Well, that assumes that the human mind is nothing but the result of putting atoms together in the right configuration.
Mm-hmm.
But that's not what life is. You know, you can die and have all your atoms the same way they were a couple of minutes before, but you're dead now. So physicists, can, it seems to me, abstract from, to do physics, the biological sciences, that is the idea of life. But life, we use the word, biologists study it, but they don't know what it is. All they know is its effects, that there's self-motion, there's reproduction, and so on. So I don't care how many infinities the universe you have of only material universe, you'll never get a brain of any kind, because a brain is something more than a collection and a configuration and constellation of little particles.
Yeah, just to distinguish, though, perhaps between brain as an organ, which has physical components, and mind, which is something which the brain is perhaps the vehicle that the mind uses, but it's not the same thing as the physical organ is not the same thing as the mind.
Yes, but I would even say scientifically that the probability of zero over infinite time of having matter accumulate in such a way that it created an organism.
Oh no, I agree completely. Wasn't disagreeing with you.
I'm not disagreeing with you either. Well, maybe I am. Go ahead.
Yeah, so not distinguish between the physical matter, which is the brain, and the transcendent aspect of it, which is the mind. That's all.
And that leads to the question of, if you think of the soul as the organizing principle of that matter, then can you even have the matter organize itself in a random way without some form, some order already being there before the matter accumulates into its bit, So even that even breaks down, you couldn't even have a brain either. I mean, then never mind a mind, but how do these things come to be without a pre-existing form that guides its development into what it is? And so, yeah, I mean, these questions are beyond my ability to answer, but
no, but the reductio ad absurdum of the scientific approach to addressing them is something which we can certainly understand. I think that is what Father Spitzer is doing here. He's showing this ultimately. This is a reductio ad absurdum. This is a really reductionist way of understanding, what we have around us. We're addressing things such as life here.
And now thinking back to this, whether it's Hamlet or Macbeth, whatever Shakespeare play, as if all that is typed letters on a page.
Right.
So even using this comparison, even if you could come up with some probability, some mathematical probability of the right letters being put in the right place, Macbeth isn't just a bunch of letters on a piece of paper. So there's something missing in this view of reality.
Well, but the distinction is, though, that if you look at Macbeth merely as a material reality,
Right.
that you have a certain number of letters following each other in spaces and so on, and quotes and counts and etc. Those are all material objects.
Yes.
And they could be strung together. I mean, they could be in any possible combination. And this 1 to the, 10 to the 123rd is the number of possible. They can calculate how many well, for example, let's take.
It's 10 to the 10 to the 123rd.
That's right, 10 to the 10. But
is that even a number?
It is.
Okay.
But it's mathematical in the sense that you can know that with one letter you got 26. Well, let's say 30 because you got commas and stuff. You got a 1 in 30 chance of hitting an A. Well, actually, let's say because it's a capital A. You have a 1 in 100 chance of hitting a capital A on that. Okay, so your chance of 1 in 100 of getting the first letter right. Now the next letter is B. Well, there's 1 in 100 chance of getting a B, so you got 1 in 100 times 1 in 100.
Oh.
That's your chance. So they can actually figure out mathematically what are the possible combinations of letters that you could have with as many letters as there are in Hamlet or Macbeth. And that's a real number.
Okay.
And therefore, it is theoretically possible that you spin the wheel enough times, you'll come out with that number.
But again, it's an astronomical figure, literally, in terms of the metaphor.
Yes, yeah.
The number of zeros, bearing in mind that every zero multiplies the previous one by 10.
That's right. But still,
it would go beyond Pluto.
Right, because this number, 10 to the 10 to the 123rd, is if every letter were a zero.
No. Oh, he's saying if every letter, if every zero on this number, if you expanded the number out to 100000000, if every one of those zeros were 10-point type.
Oh, got it. Our solar system could not contain it. Then he talks about odds, which is something different. Got it. Okay.
I mean, that is just that you think about it, because every zero multiplies the previous one by 10. You think, it's absolutely mind-boggling, and how anybody can think this is an accident.
Well, but again, it's a 1 in that many astronomical numbers chance, but it is a chance. I mean, any of those sequences have that same chance of existing, because that's how many possible ways there are of arranging letters that are that long. It's like if I said, if I get 10 letters, 10, well, say 10 numbers. That's easier because only 10 numbers. 10 times 10 times 10 times 10 times 7. From 0, 0, 0, 0, 0 to 99999, you've only got so many possibilities. And every one of those possibilities has the same chance of existing if you start from, total chance. So that's what they're saying. Mm-hmm. Yes, it's astronomical, but my point is, even if mathematically you could say, yes, it's mathematically possible that Macbeth could, come to exist in this way by a monkey tapping on a keyboard. That does not explain an organism, because for an organism to survive, is living, it has to have certain things working for it. And I'll just give you one example. There are thousands and thousands of examples. I think I mentioned it before, but for our organism to survive, we require a molecule called cholesterol. It's not a bad thing. We have to have it. Too much can be bad, the wrong kind can be bad, but you need cholesterol. And you don't get it only from cholesterol outside your body. Your body produces cholesterol. How does it do that? In the cell. In the cell, there's a process. It starts with a molecule and goes through 28 separate steps before it becomes cholesterol. At every step, there must be an enzyme, that is a catalyst, that makes that step possible. If that catalyst isn't there, it stops the operation. So you have to have, floating in the cell, you have to have these 28 catalyst enzymes that are all there together. If one of them is missing, not going to work. So what, if you talk about how evolution takes place, in which combinations are developed which are more survivable, in the environment, and then they dominate and spread their genes and so on. There's no survivable value to any particular enzyme. Mm-hmm. It only has a value if it's there with 27 other enzymes in the same cell. So that cannot happen by chance.
And this is just the cell. So, this is Darwin's black box, the cell.
Exactly.
Because he couldn't see the cell. They didn't have the magnification equipment to see cells, what was inside of them. They saw them just as little smudges, but they couldn't see inside the cell. And I think it was Darwin himself who said, if we could see inside the cell and discover it to be something complex, then my theory breaks down, because his theory was based on this idea that things were going from simple to more and more complex. And as Father just pointed out, this cell business is not simple at all. One missing enzyme and this whole thing falls apart.
I remember I have a friend who's a microbiologist, and I remember sort of saying to him about the theory of evolution. Well, we've been playing God with fruit flies now for a century. And the life cycle of a fruit fly is so short. I mean, the number of generations that we've been playing God to try to make a fruit fly something other than the fruit fly, and we haven't managed to make it anything more than the fruit fly. And my microbiologist friend said, "Well, that's nothing." He said, the fruit fly is a very, very complex organism.
Exactly.
They've been trying to turn one bacteria into another type of bacteria for a century, which is a much more basic life form, and they haven't succeeded. They haven't succeeded to make E. coli anything but E. coli. So really, we've tried to make it work, and we tried to play God with it. Try to not chance. We try to make it happen.
And in the meanwhile, out there in the ocean, some little bacterium has figured out how to eat plastic. And now they're saying that a lot of this plastic waste, these organisms, maybe they were always there, but there wasn't any plastic to eat. But now that the plastic is there, they're eating it, whatever. But, here we've been monkeying with bacteria and monkeying with fruit flies, and we keep getting, and just out there in nature, along comes this organism that is adapting itself to its environment and eating plastic. So, I mean, what's partially missing here with the people, the scientists who look at these things and measure and quantify these things and try to come up with these odds for this and odds for that? Where's your sense of wonder? When you're looking at this thing, where's your, oh my goodness, one little enzyme off and poof, and this little bacteria in the ocean, they're now eating this plastic. Where's your sense of just wonder in it all? That, I don't know. I think that's a missing ingredient in a lot of this mathematical, everything being reduced to mathematics. And then yet at the same time, you could be wondering at the math too. If you had that capacity, you'd be going, wow, look at that. Anyway.
I want to go back to one point that you were referring to either implicitly, this book called Darwin's Black Box by Dr. Michael Behe, B-E-H-E. It's a wonderful book, still is valuable. And his point there, what he calls about irreducible complexity.
Yes,
that's right.
Irreducible.
And he gives the example, and this will kind of illustrate the point I was trying to make, of a mousetrap. For a mousetrap to work, you got to have a base, a normal old-fashioned mousetrap, a wooden base, you've got to have a metal hoop, you've got to have a spring on it, you've got to have a lever that touches that spring with a trap, and they all have to be there at the same time in the right relation to each other for it to work. You can't have it evolve because the base by itself won't catch any mice, and the spring won't catch any mice, and the hoop won't catch any mice. So unless they're all there together at the same time, there's no survivability as a mousetrap, so to speak. So he says,
And that it still wouldn't work, Father, because you left out the cheese.
Very good.
well, I think we've actually kind of exhausted our time already.
That's it.
If we haven't exhausted you watchers. We'll be back. We'll be back soon.
If you enjoyed this discussion, please help spread the word about the Forum Book Club by subscribing to the podcast and writing a review. You can sign up for weekly updates at forumedbookclub.ignatius.com.